Essay 3.3 Trigonometry Applications. In this video, we're going to work on the different questions that uses the trigonometry ratios, sine laws and cosine laws, and the Pythagorean theorem. The first thing in this video that we're going to get introduced is Pythagorean theorem. The Pythagorean theorem is a fundamental relation in Euclidean geometry between the three sides of a right triangle. And it states that the area of the square whose side is hypotenuse, the opposite side of the right angle is equal to the sum of the area of the squares on the other two sides. Okay, so let's look at in this diagram here. So in this diagram, in this right triangle with the side A, B, C, and then the C is your hypotenuse, right? Hypotenuse. So the theorem states that A squared plus B squared is always equal to C squared. Okay, that is called the Pythagorean equations. Okay, so now let's talk about the angle of elevation and depression. So when you look at an object above you, that's called the angle of the elevation. And similarly, when you look an object below you, that's an angle of the depression. Okay, so when you look at this diagram, if we say there's human standing on top of the building, and from the line of the side, so this is your line of the side. Okay, if you look above you, then you get the angle of the elevation. Okay, and when you look below you, below the horizontal line, you have an angle of the depression. Okay, then let's do an example here. It makes more sense when we do an example, right? So example number 1, a flagpole cases a shadow of 9.32 meter. When the angle of the elevation to the sun is 63 degrees, we need to find the height of the flagpole. Okay, so let's say we have a ground. Okay, we have a ground here, and we have a flagpole standing like this. Okay, this is our flagpole, and we know that it cases a shadow of 9.32 meter when the angle of the elevation to the sun is 63 degrees. So we don't know where this the sun is located. However, we can say that we have a sun around here. Okay, this is our sun, and if we look up, the angle of the elevation is happening like this. We can say the angle of elevation is 63 degrees. Okay, and that the shadow is about 9.32 meter long, right? Then we can say, since we have 90 degree here, we can simply use trigonometric ratio to solve this missing height, which is the height of the flagpole that we are trying to find, right? So we know this is our angle, 63 degree, and height is your opposite, and we also know the adjacent. Then we can calculate the height by using the tangent ratio formula. Tangent theta equals opposite over adjacent. So we have a tangent 60 degree equals to h over 9.32 meters. That h is same as tangent 63 degree times 9.32. So the answer is about 18.29. Then using 3 figure, we have about 18.3 meters. Okay, now let's talk about the true bearing. So true bearing is used to describe the direction of the one object from another. And the direction is described by comparing it with the true north direction. And true bearing is often used by the pilots and the sailors to identify the directions. So that's the reason why it always uses the true north direction. So let's talk about this true bearing using the compass. Okay, so let's look at this compass together. So we have a line here between the origin O and the point P, okay, and we are trying to calculate the bearing of the point P, okay. To calculate the bearing of the point P, we need to use the true north line, which is the line here. This is your true north line, or you can also call it north line. And then the line that is created by joining the center of the compass at origin with the point P. So if you find the angle between these two lines, then that is your bearing. Okay, so if I say this angle is about 65 degree, with the true bearing, you always have to use 3 digits. So you have to write it as 065 degrees, so 65 degree. Then you can say this is the bearing of the point P, okay, and is equal to 065 degree, and this is the number of the degrees in the angle measured in a clockwise direction from the north line to the line joining the center of the compass at origin with the point P. Okay, so the bearing of a point is the number of degree in the angle measured in a clockwise direction from the north line to the line joining the center of the compass with the point, right? So you always have to think like the bearing is used to represent the direction of the one point related to another point. Okay, then let's go back to our notes. So I already told you true bearing are measured clockwise from the true north, and they are always written with the 3 digits. Okay, then let's look at this diagram. I'm going to say this is our town A. Okay, this is town B. And we have our true north lines. One here and another one here. Okay, this is our north line. Okay, then if I try to calculate the angle from our north line, the green north line, to this black line here, okay, then we can call this angle as the bearing of the A from the point B. Okay, so we can write as this angle refers as the bearing of A from B. Okay, so and if I'm trying to calculate the angle between the north line to this black line, and then you can see that we are starting from town A, right? Then this angle is called the bearing of B from A. If you look at this point here, town A point, we are trying to find the direction from town A to the town B, right? So we say the bearing of the B from A. If you look at the town B, we are trying to find the direction from town B to town A. So we say the bearing of the A from the B. Okay, then let's do an example number 2. So we have a cyclist that departs from the starting point A and cycles on 136 course for 2.4 kilometers to an intersection B, and he turns right at the intersection and drives on a 226 course for 3.1 kilometers to his destination C. We need to find the distance of the C from the A. So we have a point A, and he cycles on a 136 course for 2.4 kilometer to an intersection B. So this means if we have a true north line like this, the cyclist goes for 136 degree, okay, and cycles all the way to intersection B for 2.4 kilometer. Then he turns right at the intersection and drives on a 226 course for 3.1 kilometer to his destination C. So means he turns right at the intersection. So he creates the turns right 90 degree, and using true north line again, we know he drives on 226 course, so 226 course for 3.1 kilometer, okay, to his destination point C. We need to find the distance of C from the A, okay. So let's do this question on a new page. So he trying to identify the distance of C from the A, right? So we are trying to find this line here. Then since we know that this is the right triangle, right, we're going to use the Pythagoras theorem to solve it. So we do AC square equals to AB square plus BC. Okay. Then we know that AC square is equal to 2.4 square plus 3.1 square. So line AC is same as square root 2.4 square plus 3.1 square. So the answer is about 3.92 kilometer. So C is about 3.92 kilometer from point A. Then question B, we need to find the bearing of C from A. Okay. Bearing of the C from the A means we are trying to find the angle between the true north line to the line that is created between the point A and the C. Okay. So the bearing of the C from the A means we are trying to calculate the angle that is created or measured in degree. So the bearing of the C from the A means we are trying to calculate the angle measured in a clockwise direction from the north line on point A to the line joining the point A with the point C. Okay, so when you look at this angle, we know that this is our true north line on a point A, and we are trying to calculate the angle between this true north line to the line that is created by joining the point A and the point C, right? So we already know that the angle from here to here is 136 degree. So we just have to calculate this angle here, the one of the angle in the right triangle. Okay, so we know that we are trying to calculate this angle, and we know this is 90 degree. Okay, and we also calculate the length of the line AC from point A as 3.92 kilometer. So we know if this is our reference angle, then 3.92 is our adjacent value and 3.1 is our opposite value. That means using the trigonometric ratio tangent theta equals to opposite over adjacent, we can calculate this missing angle, right? So opposite value is 3.1, adjacent value is 3.92, then theta is same as tangent inverse 3.1 over 3.92. So the angle is about 52.3 degree. Then we can say the bearing of C from point A is same as 136 degree plus 52.3 degree. So it is 188 degree. Let's do example 3. So we have hikers Barbie and Bob, and they leave point P at the same time, and the Barbie walks 4 kilometers on the bearing of the 40 degree, then a further 6 kilometers on the bearing of 155 degree to get to their campsite. And Bob hikes to the campsite directly from the point P. And we have to solve these 4 questions. Okay, so question A. We first have to identify the how far does the Bob hike, right? So we know that the Bob hikes directly from point P to campsite, right? So we are trying to find this x value. In order to find this x value, okay, we need to identify whether we can use the right angle. We need to identify whether we can use the Pythagoras theorem or we have to use other rules to do it, right? So when you look at this diagram, you can actually see that there is a triangle happening, right? We have a triangle happening here. Okay, that means we can use like either cosine rule or sine rule because this is not right triangle. And in order to use the cosine rule or sine rule, we need to know the angle, one of the angle, at least one angle within the triangle, right? There's no angles given, so let's try to find one of the angle. Okay, so since we know there's a true north line, two true north line like this, okay, it actually creates a parallel lines, right? That means if I draw another line here, the angle here is actually same as angle here, right? Then if we identify the remaining angle, which is here, then we can identify one of the angle within the triangle. Okay, so this to identify this blue colored angle, when you look at this second true north line, this one, we know that this extended true north line has created a straight line. That means everything from the true north line to this line is same as 180. Then subtracting 155 degree from the 180 degree will help us to identify this blue colored angle, right? So we do 180 minus 155, then we get about 25 degree. So we know that this blue colored angle is 25 degree. That means the total angle here is same as 65 degree, right? Then using the cosine rule, we can say the missing side x squared is same as 4 squared plus 6 squared minus 2 times 4 times 6 times cosine 65 degree using the cosine rule. Then x squared is same as 31.71. Then x value is approximately 5.63 kilometer. Then we know that the bob height approximately 5.63 kilometers. Okay. Then question B. Question B asks us to identify the direction that bob height. So we need to identify the angle, the bearing, right? So when you look at this diagram, okay, let's clear this diagram a little bit so we can know what's going on. Okay, so we are trying to identify the bearing of the campsite from point P. That's what we are trying to calculate. Okay, so from the true north line, this line here, we know that we need to calculate the total angle from the true north line to the line that is created by joining the point P and the campsite, right? So we have we already know that the angle between the true north line and the line that is created by the point P and N is 40 degree. And we also know that this angle here is 65 degree. So we just have to calculate this part, this unknown angle theta, to calculate the bearing of the campsite from the point P. Okay, so in order to calculate this unknown theta angle, we're going to use the sine 65 over 5.63 equals to sine angle P, I'm going to call it angle P or angle theta, over 6. Then sine theta is same as sine 65 over 5.63 times 6. Then theta value is same as 74.92. Then the bearing of campsite from point P is same as 74.92 plus 40 degree. So the answer is 115 degree. Then let's calculate the question C. So question C is that Barbie hikes at 5 km per hour. This is Barbie. And Bob hikes 3 km per hour. Question I says that we need to identify who will arrive at the campsite first, right? So we know that time is equal to distance over speed, right? Then we know that Barbie hiked about 10 kilometer, right? It's a 6 plus 4. And then we know that Bob hiked about 5.63 kilometer. 5.63 kilometer. So we know that Barbie took total 10 kilometer divided by 5 kilometer per hour. So it's about 2 hours. And Bob took about 5.63 kilometer divided by 3 kilometer per hour. So it's about 1.87 hours. So we know Bob arrived first. Then question CII, we need to identify how long will this person needs to wait before the other person arrives. So we do, we know that Barbie, so CII, Barbie took 2 hours and Bob took 1.87 hours. So we do 2 minus 1.87. So we get about 7.4 minutes. So Bob needs to wait 7.4 minutes. Then question D, we need to identify the bearing that hikers walk from the campsite to return to point P, right? So means we have to calculate the bearing from the campsite. So we have to draw a true north line, and we need to calculate the bearing from this true north to this yellow line, right? So in order to calculate this bearing information, we already know that this angle is 25 degree, right? Because we know that these two will create a parallel line. Then angle here, which is 25 degree that we calculated from the question A, is same as the angle here, right? So that's the angle 25 degree, right? That means since we know that this theta angle also from question B is equal to 74.92 degree, we know that this angle is 40 degree, right? Then what we need to do, calculate the remaining angles from the interior line to here is simply 360 degree minus 40 degree minus 25 degree. So we do, the bearing is 360 minus 40 degree minus 25 degree. So the angle is about 295 degree.